Hey guys, so in today's lecture we are going to see interference and involute gears. So as the name suggests that interference, that what happens if the two mating gears are interfered, that is they are not properly aligned, so which can cause many problems while meeting, while transmitting the power. So, what can cause the interference and how we can avoid it? So, let's see with an example. So, let a pinion with center O1. So, suppose I am taking here a center O1 is in mesh with the wheel or a gear with center O2. So, our pinion is suppose uh, this direction. Suppose this is our pinion, and another wheel or gear is in this direction. So now if this they are meeting and its center is suppose here O2. So let's take a straight line here and draw here a center O2. So now if the pitch circle diameter of this gear is suppose uh, pitch circle is suppose a line passing through the center of this pinion, and the another pitch circle of this gear is suppose this line. So these are the two pitch circles of pinion and gear. Now suppose mn is the common tangent to the base circles and kl is the path of contact between the two meeting teeth. So let me take here mn as the common tangent here. So suppose this is a tangent here, which is a common. So here we need to draw first base circles, then we can draw the common tangent. So let I'm taking this as a base circle for this pinion, and this as the base circle for this gear. Now if I were to draw a common tangent which is passing through both the gear and pinion, it is a 90 degree. So this will be m and this will be n. So this will be 90 degree from here if I extend a line here. So this will be 90, and similarly this will be 90 degree if I subtend a line from here. So to the tangent it will be 90 degrees. Now the radius of this pinion is suppose small r, and the radius of this gear is suppose capital R. Now uh, now KL is the path of contact between the two meeting teeth. So here the point of contact here is suppose here L, and here we are considering as K. So now what we'll do is that if little consideration if we take it, it shows that if the radius of the addendum circle of the pinion, now we need to draw a addendum circle for the pinion. So where is the addendum circle? So this is the addendum here. So addendum circle will be this. So this will be the addendum circle here, and for this will be the addendum circle here. Oh, sorry. So these are both addendum circle. So now what I'm saying is that if the radius of the addendum circle of the pinion is increased to 0.01 n. So if it is increased to 0.01 n, so this is the addendum circle of this pinion. This I am writing here pinion, and this I am writing as gear. So if this the radius is increased to O1 n, so if it is increased till here, so if it is increased to till here, that is the maximum addendum circle. So what will happen is that the point of contact L will move from L to N. So the point of contact this will move from this to this. So the point of contact will move from L to N here. So the point of contact will move here. So when the radius is further increased, the point of contact L will be, so this point of contact of L will be inside the base circle. So it will be the inside the base circle. Uh, so so it will be the inside the base circle of the gear. It will be inside the base circle of the gear and not on the involute profiles of both tooth and wheel. The tip of the tooth, so this tip of the tooth on the pinion, this tip will then undercut. So this will undercut the tooth on the wheel at the root. So this root will be cutted by this tooth, this tip. So uh, tooth on the wheel at the root and remove the part of involved profile of the tooth on the wheel, and this effect is known as interference. So when this happens, it is called interference and occurs when the teeth are being cut. So when they cut each other, so material will be removed, or the metal to metal contact is so hard that it will cut each other. So in brief phenomenon, when the tip of the tooth undercuts the root on its mating gear, it is known as interference. Similarly, if the radius of the addendum circles of the wheel, so similarly if this radius of this wheel increases beyond O2m, so if it increases beyond this O2m, uh, yeah, so what will happen? Then the tip of the tool of this gear will cause interference with the tooth on the pinion. So this will call interference. So the point M and N are called interference points. So this and this point are called interference points. So interference may be avoided if the path of contact does not extend beyond interference points. So this can be avoided if the path of contact does not go beyond this M and N. The limiting value of the radius of the addendum circle of the pinion is O1n. So limiting value is O1n, and for the gear it is O2m. So this is called interference. Now, how we can avoid the interference? So the interference may only be avoided if the point of contact between the two teeth. So the point of contact between the two teeth is always on the involute profiles of both the teeth. If this point of contact, it is K and L, if they are on the involute profile of both the teeth, then only this can be avoided. So interference may only be prevented if addendum circles of the two meeting gears, these addendum circles of these two meeting gears, cut the common tangent to the base circles. So this cut the common tangent to the base circles. So these are the base circles. So if they cut a common tangent, then only it can be avoided. Between the points of tangency, when the interference is avoided, the maximum length of the path of contact is Mn. So maximum length is Mn. Point of contact, the path of contact is Mn. The maximum length is Mn. So what was Mn? So let me write path of contact. So it is maximum is Mn. Now Mn can be written as Mp plus Pn. Now what is Mp and Pn here? So let me go to diagram. So here the center point here I am considering this where uh, two uh, these two base circles are intersecting, so this I'm calling as P, where Mn is nothing but Mp plus Pn. So this point I'm considering as P. So Mn is equal to Mp plus Pn. Now what is Mp and what is Pn? So Mp, if you see this triangle here, so this is O1 Mp, and this angle I'm calling it as phi, and this angle will also be a phi. So what will happen here, that if I want to write this MP in the form of radius, so this length is nothing but radius, so it will be nothing but r sine phi here, and here it will be also r cos phi, but here the radius is capital R, so it will be r sine phi plus r sine phi. So if I take sin phi as a common, so we'll get r plus r, small r plus capital R, sin phi. So the maximum length of the arc of contact is equal to r. So what is the maximum? The maximum length of this is the maximum length of path of contact. But if you want the maximum length of arc of contact, then it will be equal to nothing but r plus r sin phi divided by cos phi. So we'll get the arc of the contact. So in case of addenda on pinion and wheel are such that path of approach and path of recess are half of the maximum possible values, then the path of approach, then the path of approach kp, suppose this is the path of approach here is kp, so this is the path of approach kp, and the path of recess will be pl. So the path of approach, it is nothing but, so kp is what, it is nothing but 1/2 mp, so it is at a middle distance, it is 1/2 of mp. So kp we can call it as nothing but 1/2 of mp, and similarly the path of recess, that is pl, is nothing but 1/2 of uh, np. So now what is kp and what is pl? So so the total length of contact is nothing but, so the total length, sorry, the length of path of contact, as we know that it is kp plus pl, so it is length of path of contact, so it will be 1/2 mp plus 1/2 np. So it is equal to, now we know that what is mp and np total, so we know that mp plus np is nothing but r plus r sin phi. So it will be equal to r plus r sin phi, r plus r sin phi divided by 2. So this is the length of path of contact. So now, so what is the difference between this length of path of contact? So this is length of path of contact. So this we have got it as this divided by 2, and this is also length of path of contact. But what is the difference? So this is the maximum length of path of contact, it is mn. So in the real path is divided by 2, that is 1/2. So that is the real half, that is ideal half, it should be. So this is the interference, that how interference causes. So this is the interference. Now we will see the minimum number of teeth required to the minimum number of teeth that are required to avoid the interference. So how we can avoid the interference, so that we will see in the next lecture. But today we will see another topic, that is contact ratio. So what is contact ratio? So we can call it as number of pairs of teeth in a contact. So a contact ratio or number of pairs of teeth in contact is defined as the ratio of the length of the arc. So it is defined as length of arc of contact divided by circular pitch. So mathematically this is the contact ratio or number of pairs of teeth in contact. Is the length of the arc of the contact divided by circular pitch. So as we know that circular pitch is nothing but pi into m. M is nothing but module. So for continuous transmission of motion, at least one tooth of any wheel must be in contact with another tooth of the second wheel, so n must be greater than unity. So n must be greater than unity. So if n lies between 1 and 2, so if n lies between 1 and 2, then number of teeth in contact at any time will not be less than 1 and will never mate 2. So if lies between 2 and 3, so it is never less than 2 pairs of teeth and not more than 3 pairs, and so on. So this is the meaning. Now if n is 1.6, so one pair of teeth are always in contact, whereas two pairs of teeth are in 60% of the time in contact. So this is the meaning of 1.6, that 1 is always in contact and 0.60% time, zero point 0.6 times two teeth are in contact. So these are the meanings of the contact ratio. So now we have seen the contact ratio, and we also seen length of the arc, that is length of the path of the contact and also length of the arc of the contact. So these are the three new terms which we have studied in this interference, uh, that is interference in involute gears. So uh, now we will see the minimum number of teeth required to avoid the interference, that we'll see in the next lectures. So before that, I will just let's discuss standard tooth profiles or systems. So the various standard tooth profiles or systems which are used in industries are following four types. I will say four types of profiles or systems are commonly used in practice for interchangeability. The first is 14.5 degree composite system, then 14.5 degree full depth involute system, full depth involute system, then 20 degree full depth involute system, and 20 degree stub involute system. So these are the four category which are used. Now what are these angles here, and what does this composite full depth and stub means? So first let's say for 14.5 composite system. So this type of profile is made with circular arcs at the top and the bottom. So these are made with circular arcs at the top and the bottom. So this is circular here. So this is circular. So these are circular arcs. Now if this is the center line, so this angle, is 14.5 degree. So the straight portion corresponds to involute profile, and the circular arc portion corresponds to cycloidal profile. Such profiles are used for general gears. So these are used for general gears. Then for full depth involute system, so this type of profile is made straight line except the fillet arcs. So So in full depth we are using here straight vertical lines. So in full depth we are using here slant lines for full depth. So the angle will be same 14.5 here. Similarly for 20 degree the lines will be slant, the angle will be 20 degree. Then for the stub involved system, here the problem of the interference in 20-degree full depth involved system is minimized by removing extra addendum. So extra addendum of gear tooth which causes interference. So which cause such modified tooth profile are known as stub profile, and this type of gears is used for heavy loads. So the addendum is removed here extra, so that is called stub. So these are the various tooth profiles that are used. So we'll see minimum number of tooth required to avoid interference in the next lecture, and thank you very much.